Hello class, so we'd like to look at problem set questions starting from number 66 all the way to 72. Let's try to get started together. So here we have f of negative x equals f of x. What does that mean? This basically means it's an even function. Now, in other words, even function means here it implies that the function is symmetrical about y-axis. Alright, so knowing all those things, we get to realize if 2, 4, and negative 1 are some roots of this function, where this function, as you can see, has 60th degree, that means we should have 6 roots. Then where are the other 3 roots? Simply put, so let us assume that 2 is one root, and then 4 is another root, and negative 1 is the third root. Then what we end up getting is 2 by the even function. Then we get to realize that negative 2 will be the other root. Given that 4 is one root, that means negative 4 is the other root. The fact that we have negative 1, that means 1 will be its corresponding root. So here it goes there. That's how we could have 6 of them. Now, then, the question is b over a. b over a is, in fact, since this is the first coefficient after the leading coefficient, this in fact implies the sum of the roots. But when you look into sum of the roots, when you add up negative 4, positive 4, negative 2, positive 2, negative 1, and positive 1, then we get to realize the sum of the roots has to be equal to 0. And that is in fact true for any even functions. Now, let's look at the h of a. H over a. H over a is the last number over the first number. That's always the product of the roots. But let's look at it. It can be sometimes product of the roots can be either positive or negative. In fact, if I have to go back, some of the roots technically supposed to have a negative sign in front of it, but either way it becomes 0, so I just ignored it. But here we have to realize that for a second here, this was always positive. Some of the roots would have been negative, next coefficient, and then if this one next coefficient would have been positive, negative, positive, negative, positive. So in fact, positive h over a will be the product of the roots in this case. So if you were to multiply all 6 of them, what do we end up getting? Negative 1, positive 1, negative 2, positive 2, negative 4, and then positive 4. Since we have 3 negatives, our final answer will be negative. And then here, 4 times 4 becomes 16 times 4 becomes 64. So negative 64 becomes our answer for part B. Alright, let's move on. Number 67. F of 3 is equal to 2 and f of 5 is equal to 0, and we need to find out k and j, where this one is true. Now, f of 3 being equal to 2 can be compared to this way. Then simply means k squared plus 2k will be equal to 3. Let's try to take care of that first. K squared plus 2k must be equal to 3. That means k squared plus 2k minus 3 would have been equal to 0. Now, this is in fact factorable, where k plus 3 and then k minus 1 will be the factor of this one. And they didn't say anything about being positive or negative. So here, we get to realize that k must be equal to negative 3 or positive 1. Then let's look at second one right over here, f of 5 equal to 0. That means I can compare that with this expression where a square root of j minus 3 must be equal to 5. Now then when we square both sides, then j j minus 3 must be equal to 25, where j must be equal to 28. And I guess that's about it. Let's look at number 68. Given this function, g of x is a result of mapping this original given function after these two transformations. So in this case, basically what we're looking at is we need to figure out the general rule for this one. Translation and then followed by rotation. So here, let's try to look into this one for a second. So let us say, if I were to call this one as old x and then old y, or x naught y naught, basically what we're looking at is translation by 2 comma negative 1 followed by rotation of the 90 degrees. Now, then this we'll try to do the translation first. And this is equal to x naught plus 2 comma y naught minus 1. Actually, why don't I just write it out a little bit differently? The same thing is first doing the translation 2 comma negative 1, and then we'll try to do the rotation by 90 degrees. Whenever we want to do rotation by 90 degrees, we just have to move the y values to the front and then negate it. So what we end up getting is negative y naught plus 1 comma x naught plus 2. Now, then this is our mapping, whether we go one at a time or both at the same time. Then we get to realize that this must be our new x, and this must be our new y. That means our x is equal to negative y naught plus 1. This implies that y naught must be equal to negative x plus 1. Basically solving for y naught. Here y is equal to x naught plus 2. So here we get to realize that x naught is equal to y minus 2. Alright, then using this conversions, what we end up getting is, we get to realize that if I were to just use the x and y here to express the given function, our original function used to be y naught is equal to 2x naught squared plus 3x naught minus 7. If that follows the same procedure here, then what I'm going to do is, in place of y naught, I'm going to put this one, x naught. I'm gonna put in place of y naught, I'm going to put this one. So we end up getting negative x plus 1, which is equal to here 2 times y minus 2 squared plus 3 times y minus 2 minus 7, and that becomes our answer. Of course, you can solve for y now, because that's what we are looking for here, g of x. Then let us just continue on this one, expanding this expression. Then here, so this is the answer, but if you have to rewrite this one, what we end up getting is this. I'm going to just write down negative x plus 1, which is equal to 2 times y squared minus 4y and then plus 4 plus 3y minus 6 and then minus 7. Now if I had to combine this one together, so negative x plus 1, which is equal to 2y squared, and then this becomes negative 8, but with the plus 3, so we end up getting negative 5y, and here positive 8 minus 6 becomes 2 minus 5 becomes negative 5. And if I have to bring everything onto one side, then this becomes 0 equals 2y squared minus 5y, and then here we end up getting negative 6 plus x. Now how am I going to solve for y? In fact, we could use the quadratic formula. Y then becomes 5 plus or minus square root of 25 minus 4 times a, which is equal to 2. C becomes x minus 6 all over 4. So that's basically what we end up getting. Now, then just to simplify, we end up getting 5 plus or minus square root of 25 minus 8 times x minus 6 all over 4 becomes our answer. To make it into a function, we could either pick positive or we can just pick negative. Either one is fine. All right, and that would be the expression of our g of x. How about the next one? We have another parabola, but we want to dilate this one by the factor of this, about this point 2 comma negative 1. So what we need to do is this. If I were to show you the graph and then see what happens, it might be a bit better for us to understand. Okay, so here, once again, if we know the general rule for this transformation, then we can just apply that for our equation here, function here given. But we need to realize that what is 2 comma negative 1? 2 comma 1 is right over here. So any value of x and y has to be measured from here, this particular point. So if, for example, if this one is our new center, so if let us say if I have just randomly this particular point, let me just use a different color. Normally we would have said 2, 4, 6 comma 2, but based upon our green origin, this will become 4 comma 1. Now, how does that happen? By translation of subtraction by negative 2 comma negative 1. That's basically what we end up getting. That's the first step. And then after we rotate this one or dilate this one by the factor of 3, that means this will become now 12 comma 3 based upon the green point. So 12, that means we got to go a little bit here, and then 3 becomes, we're going to go around way over here. Actually, you might have to move a bit further. But this value, if you have to recalculate this one on the actual origin right over here, 0 comma 0, then this has to be counted by x by 2 more values and then y by 1 more value. So in fact, this becomes 14 comma 4. Now, if you were to apply these kind of logic in general rules, such as this one, x naught comma y naught. In order for us to dilate this one by the factor of 3 about 2 comma 1, what we need to do is first we need to translate this one by negation 2 comma negation 1. So this becomes x naught minus 2 and y naught minus 1. Now, then it will go through the dilation by 3. Dilation by 3 about the new origin, which is right over here, 2 comma 1. Let me just write down there was a translation by negative 2 comma negative 1. Then this will be now equal to 3x naught minus 6 comma 3y naught minus 3. But after that we have to read it from the actual origin, so what's going to be happening is we're going to translate that back onto 2 comma 1. Then what we end up getting is final answer. Here would have been 3x naught minus, instead of 6, but it will be minus 4 comma 3y naught. Instead of having -3, it's going to be -2. And that becomes our answer. So in other words, our new x becomes 3x naught minus 4. And this implies that our x naught, after calculation, we get x plus 4 divided by 3. That's basically what we end up getting. Now, our new y is in fact equal to, right over here, 3y naught minus 2. So if you have to solve for y naught, becomes y plus 2 over 3. Now, then let us try to use this one to get our result. What is an equation? In this case, I didn't ask you to solve for y. So in fact, we can just write down our answers as it is. So here, I can consider that as y naught. Our original function was y naught equals 3x squared and then plus 5. But it will go through the dilation by factor of 3 about 2 comma 1. And so therefore what we're going to do is, in x now we're going to put this one, and y now we're going to put this one. So we have y plus 2 over 3 is equal to 3 times x plus 4 over 3 squared plus 5. That becomes our final answer. Alright, let's move on to the next question. Number 70. What is an equation of the image of this after rotating this one about negative 1 comma 0? So once again, we need to know the general rule. This time I'm just going to continue doing it instead of drawing a example. So here basically we're going to rotate this one rotate 90 degrees about negative 1 comma 0. So then first step, we're going to apply the new center by having the opposite of that. So t comma 1, t of 1 comma 0. Then our answer becomes x naught plus 1 comma y naught. Now then apply the rotation of 90 degrees about the new origin, which is negative 1 comma 0. Then here we end up getting negative y naught and then x naught plus 1. Then we need to move this one back onto read it off from the original origin, which is 0 comma 0. So we gotta translate this one by t negative 1 comma 0. That means our final answer would have been negative y naught minus 1 comma x naught plus 1. So here we can conclude that our new x is this negative y naught minus 1. This implies that y naught is equal to negative x minus 1. And our new y value is this way. So x naught plus 1. That means this implies that our x naught is equal to y minus 1. Alright. Then in this case, our equation was y equals square root of x plus 4. So y equals square root of x plus 4. Since this is original, I can call that as a y naught equals square root of x naught plus 4. And it will go through the rotation of 90 degrees about negative 1 comma 0. Then our answer becomes negative x minus 1, which is equal to square root of x naught, which is y minus 1 plus 4. So I can simplify this one just a little bit, or I can just leave that as it is. That's perfectly fine. Then I'd end up getting negative x minus 1, which is equal to square root of y plus 3. And that becomes our answer. Alright. And here, since I didn't ask you to solve for y, so this will be acceptable answer. Now, the last one is what is an equation of this? when it's reflected about 1 comma 0. Now so then we need to know the general rule first. X naught comma Y naught is going through the reflection about 1 comma 0, not 0 comma 0. In fact, I can do either one. In this case, that's equal to reflection about the, or let me just use the small r to represent the reflection, because I use the big R for rotation then. So first, y value is equal to 0. Y equal to 0, that means simply x-axis. Then here, if I were to reflect these points, general points, reflected about the x-axis, that means x stays as x naught, while y becomes negative y naught. Now, take care of the other one, which is reflection over x equals 1. That means what we end up getting is y value stays the same, but x value will be now 2 minus x naught comma negative y, or y naught. That becomes our answer. So in fact, yes, that becomes our answer. So what I'm going to do is, maybe I'll just group them and then rotate it just a little bit. So that is our final answer. That means this implies that our x value, new x value, is 2 minus x naught. This tells us that x naught is equal to 2 minus x when you solve for x naught. And here our new y is equal to negative y naught. So that tells us that y naught is equal to negative y. Then here our equation is y naught is equal to x minus 4 squared plus 2 goes through the reflection about 1 comma 0. Then our answer is, oh, this is x naught. From here, y naught, I'm going to put negative y. And then parentheses x naught, I'm going to put 2 minus x. So 2 minus x minus 4 square plus 2. Then if I have to solve for y a little bit, even though they didn't ask, let me just clean this one up just a little bit here. Then we end up getting y equals negative, after we calculate this one square, and minus 2. If I have to simplify this one, then 2 minus 4 becomes negative 2 minus x. I can leave this this one as it is, but if I were to square them, this is the same thing as y equals negative x plus 2 square minus 2. If you look at it just a little bit, then you will realize that these are identical. Alright, so let us move on to the next question. Here, number 72, a parabola with an equation such as this one has vertex h comma k. So let's just assume something here. As an example, we have and reflected about y equals k. So what if I have a parabola something like this, and we can see that this is y equals ax squared plus bx plus c. This is x-axis, this is y-axis, and that point, the vertex, that's the h comma k. Now, or x or y equals k. So what I reflected about y equals k, that means I'm gonna maybe use this line, and I'll say that's equal to y equals k. this results in a parabola with the equation. So then obviously, graphically speaking, I'm going to clone this, maybe change the color a little bit. I'll call it blue. But I'm going to flip this one upside down. Then it's going to be right over here. How about that? So blue one would have been our equation. That is the reflection of the red one about y equals k. So here we get y equals dx squared plus ex plus f. What is the value of a, b, c, d, e, f in terms of k or h, or both, I guess? Now, the fact that I have coefficients alone, that's only possible if x equals 1, then we're going to have y value is equal to a plus b plus c. If x equals 1. And that is the same here. So why don't I just call it y sub 1 this way. Here, if once again x equals 0, or x equals 1, y sub 2, in this case, y value here, is equal to d plus e plus f. So what the question is asking for is to find y1 plus y2. Question is y1 plus y2. Now that means, physically speaking, if this one were to be 1 over here, then this will be our y2 value, and this will be our y1 value. But you get to realize that something, this is somewhat interesting, because y1 can be, from k, y1 can be expressed as k from y value plus some portion, what would I call it as, maybe p, if this portion is p. So k plus p would have been y1, and y2, by symmetry, this would be also p. y2 would have been k and minus p. So in other words, what I'm looking for is y1 plus y2. Then in this case, we get to realize k plus 1, k plus p, plus k minus p. Then our final answer is simply 2k, and that becomes our answer. All right, have a great day. I'll see you later. Bye-bye.